Welcome everybody. We're going to take a look at Bohr diagrams and Lewis dots. So we should have a periodic table handy, and hopefully at this point you've completed the lecture notes that kind of go through this step by step, but I figured I'd just show you some of the examples with the practice. You should be good with determining how many valence electrons each element has, what shell those valence electrons would be in, whether you're going to get a positive charge or a negative charge, and what that oxidation number or that charge value would be. If I talk to you about groups or families, that should mean something, as well as periods and rows. If that's all like, yep, got it, Cash, let's get a move on, fantastic. If not, you're going to want to revisit some of our previous discussions. So with that being said, we've got two things here that you should be able to do. You should be able to make Bohr diagrams, and these are named in honor of Niels Bohr, the electron genius, and the contributions from Mr. Gilbert Lewis, the Lewis dots. So what I found is when we go to wrap up this unit, test time comes. A lot of kids are good with making Bohr diagrams and making Lewis dots, but they forget which is which, and then they make a Bohr diagram where a Lewis dot goes or a Lewis dot where a Bohr goes. Make sure you keep those straight come test time. So the Bohr diagrams, they're going to really kind of contain more information, and then the Lewis dots, they're going to just focus on the valence electrons alone. So the Bohr diagrams kind of show us everything visually, and Lewis dots get to be more and more important as you get into higher levels of chem and you're trying to sketch or draw out different compounds. So I'll do an example here for you. The Bohr diagram, this first one is helium, and I know helium's over here in group 18, and it's kind of a little trickster because these guys all have 8 valence electrons, but helium's only got 2, but that's maxed out. So from the lecture that's associated with this practice, we saw that first shell, all these guys in group or period 1, can hold a maximum of 2 electrons. Well, what if it's got more than 2 electrons? Then it spills over into the second shell or level, and it can hold a maximum of 8 electrons. What if it's got more than that? It spills over into the third, which can also hold 8 valence electrons. And we're not going to focus on 4, 5, 6, 7. Those shells or energy levels with this. We're just going to kind of baby step through these first 3. So here's something to kind of consider. Cash, this only holds 2 in this first shell. That's correct. Look at 1, 2. So that would make helium's shell full, and it's going to be happy. And that's why it's a noble gas and doesn't want to react. It's got nothing that it wants to change about its old valence electrons. It's got that full outer shell. So 2, second shell can hold 8 more. By my calculation, 2 plus 8 is 10. Holy smokes, neon is 10. So that would mean that it's got its first shell and that second shell filled. Well, 10 plus another 8, the maximum that this third shell could hold would be 18. And looky, argon's got 18 for its atomic number, which means if it's neutral or balanced, there'd be 18 electrons there, filling up its first, second, and then that third shell would be filled as well. So here's how you do a Bohr diagram. Okay, we've got 2 for our atomic number. So I'm going to say helium, and then I'm going to put 2 protons in my nucleus, right? Right. So now I have to show all of the electrons present. All right. Well, I got to show 2, and I know that first shell can hold 2. 1, 2. Booyah. That's a good looking Bohr diagram. So if we were to take a look at another one, which we'll do here in 1 second, I'm just kind of scrolling through and looking at these guys. I like carbon, and I guess it's the next one, so we'll do that. So I find carbon. Carbon lives here. It's got 6 protons. So with that being said, I'm going to draw in the C, which sometimes you won't see a C there, or like the symbol. You'll just see like 6+ or something to that effect. I've just given you a little bit more information here. So we'll go carbon. It's got 6 protons in its nucleus. So that would mean that if it's balanced, it's going to have 6 electrons to balance out those 6 positives. Well, the first guy, and by first guy I mean that first shell, it can hold 2 electrons. 1, 2. Notice how I kind of located them where you can see them nice and neat. Cash, I got to get to 6. That's true. My first shell's filled. So guess what? You got to start working on your second shell. So we're going to have 1, 2. We got to get to 6. Usually how you draw these is start here and then work your way around. And I know that I said that this could hold a maximum of 8. So if I were doing something like neon, I would double up here, 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 and here, making those paired electrons. These would be unpaired. So here's something else that's kind of neat. We've been at a spot where we know how to figure out how many valence electrons each element has and what shell it's in. So before this activity, if I said, kids, where's carbon's valence electrons? You know, you should be comfortable saying, well, 1, 2. It's in that second period or row. So carbon's valence electrons are in that second shell. And if I said, all right, well, how many valence electrons would be there? 1, 2, 3, 4. So carbon would have 4 valence electrons in its second shell. Looky, looky. 1, 2, 3, 4. 4 valence electrons in 1, 2, that second shell. So that's the way you work with the Bohr diagrams. The Lewis dots, there's less information there, but you're usually using them when you're showing like how things are going to end up forming compounds and molecules and whatnot. We're just looking at some elements and how we draw the Lewis dots for those. So here's what you got to do. Here's potassium. I'm going to kind of draw mine off here so I've got a little bit more room. So there's potassium. It's got 1 valence electron. Check. So I got my symbol. Boom. 1 valence electron. That's all I have to show. Now, this shows me that it's got 1 valence electron. What if it had more? You want to kind of pretend, you don't have to like sketch these little lines here, but you want to kind of pretend that there's a box around there so that if you're going up to 8 valence electrons, you would go around and try to have it like squared off. And what I mean by that is you wouldn't want to have an element like this and then you're just kind of filling in yours everywhere around, so it's like a circle. You want to pretend that it's kind of boxed. And if this is our element symbol, the first one goes here, then 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 here. So it kind of has this max of 8 and they're sort of boxed. It makes it easier to see if you can kind of like have your paired or your unpaired valence electrons easily visible. So let's take a peek at another one here. We've got fluorine, and I'm going to draw that just over here so I got a little more space. I scroll around. I find fluorine lives there, and I count it out, and I know fluorine has 7 valence electrons. So again, I'm going to pretend that there's like an imaginary box around there, and I've got to show 7. So I start off 1, 2, 3, 4, 5, 6, 7. And that's all there is to it. So if you've got questions with the Bohr diagrams or the Lewis dots, please feel free to reach out and I'll be happy to help you. If you're good, fantastic. Niels Bohr, the electron guru, he's got these Bohr diagrams, kind of show us all the information. Gilbert Lewis gave us these Lewis dots. They're just focusing on the valence electrons. Till we meet again, be safe.